Hey gang, welcome to the Worksheet Solutions Walkthrough for Chirality and assigning RNS. You know the drill by now. You've seen an instructional video on jOeCHEM, you looked at the worksheet that went along with it, you did it, maybe you looked at the PDF answers, you wanted a little bit of an explanation. Well, you're in the right place. We're gonna do the worksheet here, you're gonna see how I would arrive at all the answers, so enough talking, let's do the worksheet. Okay gang, so in problem one, we have a pretty simple task ahead of us. In 4 different situations, we need to look at each of the following structures and determine if the structure is chiral or achiral. Now remember, chirality, it's that handedness that we talked about. If you are chiral, then you have a non-superimposable mirror image, meaning, my hands are chiral. This is my left, your right, but there exists a mirror image of this hand, but I can't superimpose them, right? I can't put one on top of the other. So in OCHEM, right, so the hand example, that's great, but in OCHEM, remember, that means we need at least one stereocenter or stereogenic center, same term, and that means we need at least one center that's a carbon that's attached to 4 different things. However, that's not the only thing. We need to make sure that we have that condition, but we also need to make sure the molecule does not have a plane of symmetry. Okay, those 2 things. So if we look at, in problem 1, the letter I, we look at this structure right here. Now, is there anything that's attached to 4 different things? The answer is no, right? We have this carbon in the center, and that carbon's attached to 3 CH3 groups. They have this tertiary carbon, so that carbon is in a stereocenter. And then every other carbon here is attached to at least more than 1 hydrogen. So we have neither condition, satisfied here. So this is an achiral structure. Okay, now problem 2. So when we take a look, we see this carbon right here. Obviously we have this carbon right here, but we can see that that carbon is attached to 3 hydrogens. This carbon, certainly not a stereocenter, but this carbon right here has some hope, right? Because we see a fluorine, a hydrogen, a CH3, and a chlorine. So 4 different groups, and there's no plane of symmetry here. So this structure absolutely is chiral. Okay, cool. So, letter I, 3. So, if we take a look here, right, none of these carbons satisfy at, qualify as a stereocenter, right? Because there's 2 hydrogens there, 2 hydrogens there, 2 and 2 and 2. So, not 4 different unique things. Now, if we take a look at this carbon, then I'm going to dot. Oh, and this carbon has, 2 hydrogens, this has 3, so they're not in the running as well. However, if we take a look here, right, we see a wedge and a dash. That doesn't necessarily mean anything, but it's interesting. So we see the ethyl group, we see this hydrogen. However, right, what about these right here? Well, if you can see, if we follow both of these groups, we kind of run into the same position, and that goes to say that neither of these groups right here are, this is the same group, if you will, because they both lead. There's no point of difference, right? They end up leading to the same position, so they're the same. Also, even if there was the case, that's actually the point I was trying to make. This group going this way and this group going this way, they are the same, so we are not attached to 4 different things. This is achiral. Okay? And last but not least, if we look at 4 in problem 1, now it looks like we are absolutely chiral here, right? So not this carbon, not this carbon, not this carbon, but this looks promising. However, do not get tricked. Just because I put a wedge and a dash here does not mean that there are 4 different things. There's a CH3 here and there's a CH3 here. So we are not attached to 4 different things. This is achiral. Okay? So don't be duped by a wedge and a dash. Make sure you're actually looking at 4 unique things like we were in the second one of this problem. Okay? Problem 2. So in problem 2, I'm just going to take, I have the two columns of 2. I'll take it a row at a time. So in this first example right here, I've indicated which, where the stereocenters are and where you should be assigning RNS. So if we take a look here, remember, when we assign RNS, we need to make sure, or we need to check, is our lowest priority group facing away from us? If so, that's great. We can just assign RNS straight away. If our lowest priority group, by weight, right, atomic weight, is coming at us, then we can just assign and take the opposite. Or we can use the double switch, which maybe this video is a little bit behind the double switch, but there's no double switches in this worksheet. So if we take a look at this example, right, let's start with this Stereocenter. So what we first need to look at is is our lowest priority group facing away from us? The answer is yes, right? This hydrogen is the lightest thing that's attached to this Stereocenter. So we will go ahead and give that a 4. We have peace of mind knowing we can just assign, and then that is the configuration for the Stereocenter. Now we need to think, where is our highest priority group? Now that is going to be going this way, right? Because we have a CH2 here, a CH2 here, and a CH2 here. So that's a tie. So we need to keep going to break that tie. So here we have we have a carbon that's attached to 3 hydrogens. Here we have a carbon attached to 1 carbon and 2 hydrogens. So this already loses, and it's this carbon here that's attached to 2 hydrogens and another carbon. So we need to continue going because while this group lost out, these two tied. So if we go one more, and we go one more, this carbon is attached to 2 hydrogens and a carbon. This is attached to a carbon, and a hydrogen. So this group right here ends up winning. Then, given the tiebreaker, we know that going down this way is a higher priority group than up here. So then this is 3. So if we were to assign, remember we take out our molecular steering wheel, and if we go this way, right, we turn the wheel right, this is R, right here. Okay? No need to draw the arrow, just making sure I actually draw the letter. And so then here, we can use very similar logic. We know that this way is going to win this way, beat out this way. Then second group is going down this way. The CH3 is 3rd, and our lowest priority group is facing away from us. So again, we bust out the molecular steering wheel. We know we're turning this way, and that is S, right? R for right, S for left. Okay, so that is how we got R and S over here. Now if we go over here, chlorine is heavier than carbon by a mile. So right off the bat, chlorine is our highest priority group. Oh, and before I get ahead of myself, what's the lightest thing that's attached to this carbon? It's the CH3, because here we have carbons here that are part of a longer chain. So this CH3 is the lightest thing. Lowest priority group is facing away from us. We have peace of mind to just assign R and S, and that is exactly what the configuration is. So 1 here, and I hope you can see that, going over here we have a secondary carbon, going up here we have tertiary carbon. This is attached to heavier things, right? Because, and let me show you how I really arrived at that. So this carbon up here is attached to a carbon, and 1 hydrogen, C, and H. This carbon over here is attached to 1 carbon and 2 hydrogens. So you kind of go through the tiebreaker. These are equal, but then this beats out the hydrogen, so it's this group that ends up winning priority. That's what I was doing in my head over here. And then 3 over here. So remember, we take out our molecular steering wheel, we turn it this way because we're going in the direction of 1, 2, and 3. So we have R, and we know it's R because our lowest priority group is facing away from us. Okay, so I'll erase this, and we'll do the second row. In the second row, we have 2 rings, so let's get after it. So if we take a look here, I have 2 stereocenters right here. Remember, this isn't a stereocenter here because there's 2 CH3s. So what I'm going to go ahead and do is I'm going to fill in the hydrogen at this position, which is not explicitly drawn. So I hope what you're seeing is down here, our lowest priority group, the hydrogen, is facing away from us. We can just, peace of mind, assign R and S, and that's what the configuration will be at this Stereocenter. But up here, right, we can still assign R and S, but we have to remember, since our lowest priority group is facing towards us, that's the opposite of our conventions, we'll have to assign and then take the opposite. So if it's R, it'll be S, and if it's S, it'll be R. Okay, so let's look up here. Now remember, we have a halogen here, and fluorine is in the periodic table, right? We have nitrogen, oxygen, fluorine, carbons over here. So fluorine is heavier than carbon, so no matter what's attached, fluorine wins. So fluorine is priority number 1. I'll put 4 on hydrogen. So now we have 2, we have a carbon here that's attached to 2 things, and a carbon here that's attached to 2 things. So again, to show you how I'll break this tie, if that carbon is here, this carbon is attached to 3 carbons, 1, 2, and 3. C, C, and C, right? And I'm not showing the 4th thing it's bonded to because it's that carbon, right? So then this carbon over here is bonded to a bromine, a carbon, and and a hydrogen. So you can clearly see right off the bat, this carbon is second priority going down this way because of the bromine. It trumps everything that this carbon is attached to. And then over here by default, this is 3. So if we break out the molecular steering wheel, we're going in the direction of 1, 2, and 3, right? You just go 1, 2, 3. So kind of ignore 4. I never really put 4 there. So it is in this direction. So we're turning the wheel right. But remember, we look R, but because our lowest priority group is facing us, we are actually S. Okay? Just double checking myself. Yep, S. Okay, cool. So down here, we can kind of use the same analysis that helped us. So bromine is the first because it's heavier than any carbon we might be attached to. This is just a plain CH2. This carbon is attached to a fluorine, so up here is second. This is third. Hydrogen is fourth. We're going in the direction of this right here. Our molecular steering wheel is going to the left, so we know that is S because our lowest priority group is facing towards us. No need to flip the configuration. Okay? Cool. Onto the 5-membered ring. So if we take a look, let's start at the bottom this time. So if we take a look, we can see that right off the bat, it's basically a battle of the carbons, right? So at this position, this will be our highest priority group. And let me, before I get ahead of myself, come on, black marker. We have a hydrogen down here I have not filled in. So lowest priority group is facing away from us. That's good and dandy. We can assign and have peace of mind. So this T-butyl group is the first priority because this carbon is attached to 3 other carbons, and these 2 carbons are attached to hydrogen. So this wins out. Now we need to break the tie between these branches right here. So here there's a tie, and I think here we have another CH2, but here we have a whole lot more interesting things, and this carbon's attached to that CH3. So this side is second priority. This is third. Break out the molecular steering wheel. We're turning left, which means we are S. Okay? No need to flip it, right? Because lowest priority group is facing away from us. And then up top, right, we have the way this will go. So lowest priority group is facing towards us, so we have to take the opposite. But this is our first priority group because it's the same logic that we just used down here. We have a tie here, but the tie is broken when we move to the next position. This is second, and then the CH3 is third. So we are turning R, but remember, the lowest priority group is facing towards us, so we look R, but we are actually S. So actually SS, SS. All right, third row to finish out problem 2. Row 3. So when we take a look here, let's take this structure first, and let's start at this marked Stereocenter. So I hope you are looking at this recording, you're thinking, Joe, clearly iodine. It's huge. It's a lot of junk in the trunk. You're absolutely right. So here, that is the first priority, and I keep forgetting to do this, but just in case, because I know we're still new in Stereochem land, right? Our lowest priority group, this hydrogen, is a wedge, and over here it is a dash. Let me just mark those quickly. Okay, so now we need to decide 2 and 3, because clearly we know this is 4. So I hope you're seeing that the CH3 does not compare to the length, whatever this group is right here. So going this way, that's priority 2. This is priority 3. So if we take our molecular steering wheel, we are going to the right. However, it's not to the right. It's actually to the left because our lowest priority group is facing towards us. So this Stereocenter is S and not R. Okay? Now, if we take a look over here, let me erase this so I don't confuse anybody. So, myself really, here, right? So we have a bunch of carbon ties, CH2, CH2, right? Attached to a carbon, and 2 hydrogens. This carbon wins for priority number 1 because at this tie, it's attached to a CC and then just 1 H, okay? So, now who's second, right? We have this, ethyl group and then this chain over here. So I hope you're thinking, okay, this chain there's a lot more going on here. We're gonna keep tying until we hit this right here because this is CH3 and this is a carbon that's attached to 1 carbon. And then over here, priority number 3, lowest priority group is facing away from us. So we're turning our rail to the right. Lowest priority group is facing away from us. So this looks and is R. Okay? Now, final one over here. So lowest priority group, the hydrogen is facing away from us. Bromine's the heaviest. Chlorine comes in second. Ethyl group comes in last. We look like and are S. Okay? That does it for problem 2, Yang. problem 3 to round out this video. Okay gang, so problem 3, I'm going to do one at a time because I'll probably need the space to show the double switch. I'll at least do it for the first couple ones, then maybe we'll skip a bit as we go on. Alright, so the first of 6. I'll just write this up here. Okay, so very similar to the last problem we did, and you'll see it's actually very similar, but our lowest priority group, the hydrogen, is in the plane of the paper, the board, whatever you're working on. We need this lowest priority group to be either facing towards us, coming at our faces, or going away from us, back, through the plane of the paper, board, whatever we're working with. So what we can do is if we switch a pair in Stereochem land, whatever configuration we have here, which we don't currently know, if we do a pair switch, we'll get the opposite. And then if we do another pair switch of a different group of 2, we will then get back to our original we'll recover our original stereochemistry. So what we'll do is I'll do number 1. I'm going to swap these 2 because I want to get my lowest priority group facing away from me to make my life very easy. So now I've inverted my stereochemistry. So we are currently at the opposite stereochemistry of what we originally had. So what I can go ahead and do is do another switch. And I'll do something like, I'll swap the ethyl and the bromine. CH3, and have this ethyl group. Okay, so it's important to note, these 2 are the same. We've just done a double switch, so it's basically as if we had done the mental gymnastics to rotate the bonds, but this is a process, it's repeatable, it's easy, I like it, so up to you. So let's assign Stereochem over here, and it'll be the same over here. So, lowest priority, so 1, 2, and 3. Oh, this is slightly, I'm forgetting my own problems. So yeah, 1, 2, and 3. So you'll see that our molecular steering wheel is going like this. We're going S. Okay? So that is the first of the 6 problems here, so let's keep going. 5 more. Okay, gang, so in the top right example, I'm going to just show the double switches, and then we can just go to the end and assign R and S. So, lowest priority group, the hydrogen, in the plane of the board. That's a bit of a problem, but not for us because we know how to double switch. So what I did here first is I went and I flopped these 2 groups. Then over here, I flopped the bromine and the isopropyl. So, having done 2 switches, I'm now in a position where this structure is equivalent to this from stereos, they're identical actually. So, bromine, highest priority. This isopropyl group is 2nd. This is 3rd. Obviously, the hydrogen, lowest priority group, is facing away from us. So, we look like we are going to R, and in fact, that is the configuration at this Stereocenter. Next example. Okay, gang, so in this problem, the first thing I did, I saw that my hydrogen in the plane of the board, going to be a broken record here. So I knew I needed to do a double switch to invert some stereochemistry, then recover it, but then ultimately get this in a position that was either facing me or facing away from me. So in this first switch, I did a chlorine-hydrogen swap to get it facing away from me. Then I knew to recover my stereochemistry, I had to flip any 2 other groups. So I did a bromine and chlorine swap. It's important to note, at this point, it doesn't matter. You can switch any group. Just don't switch the group you did in the first, because then you've just undone all the hard work you were starting to do. So at this point, now it's just about assigning priority. So bromine takes 1st, chlorine 2nd, this CH3 comes in 3rd. Obviously, H facing away from us is the lowest priority group. We get out the molecular steering wheel, we're going to the left, which means we are looking S. Okay, next problem. In the middle right problem, we start off here. Again, we see hydrogen, lowest priority group, in the plane of our page board, and that's a problem, so it's double switch time. Right, so the first thing I did was let's put it in the position that we really wanted in, facing away from us. So I just did a swap of the iodine and the hydrogen, right? So now I've inverted my stereochemistry, I need to recover that stereochemistry. So I need to do a switch. And here I just decided to, switch this propyl group with the ethyl group. So here is our final structure here, equivalent to here in every way. So iodine, super giant, heavy, takes first prize in assigning priority. Then we have the propyl group because it will eventually beat out the ties it has with the ethyl group. ethyl group comes in third. We take out our molecular steering wheel. We're going to the right. This stereocenter is R. And we're moving on. Okay, gang, so in the bottom left-hand problem for number 3, we see that we have 2 stereocenters. And upon inspecting them, we see that the one on the left, actually we don't have to do any double switch on, because the hydrogen, our lowest priority group, is facing towards us. And we can handle that. We just have to assign the configuration and then take the opposite, because the lowest priority group is facing towards us, opposite of our convention. Now, if we look over here, yeah, we can psi, because this hydrogen is in the plane of the board or page or whatever you're working on, so we have to double switch over here. So if you can see, going from here to here, I've only double switched on this side. I've left this side completely intact, the same. So right here I just did a CH3H swap over here. Then I did a CH3OH swap. So now over here is something that's more user-friendly, right? Exactly equivalent to over here, but more user-friendly for our stereocenter assigning purposes, configuration assigning purposes. So let's handle this side. So the OH is the highest priority on both sides, but definitely over here. Then it's going to be this carbon over here, because this carbon is attached to an oxygen, so that easily trumps the CH3. CH3 comes in last. Lowest priority group is facing towards us, so we are looking like we are R here, but we are actually S. Okay? Now I'm going to erase these numbers, just because I don't want to get a little crowded. Over here, same deal, first, second, and third. Now here, lowest priority group's facing away from us, so just assign and leave it. So we are looking S, so we are S. So we have 2 S's here. So one more, gang, stick with me, we're almost done. I realized in that last take, I said that 5th was actually bottom right, but that's bottom left, so oops. So last one, gang, if we take a look here, I like this problem just because it really illustrates the concept of breaking ties, right? We basically just have alkyl groups, but at this position we have varying, that's a secondary carbon, that's a tertiary carbon, that's a quaternary carbon. So you can see how the ties are broken when you have very similar groups, kind of. So, broken record, hydrogen, our lowest priority group here, is in the plane of the page. We have to do something about that. We really want it either facing towards us or away from us. It's double switch time. So I switched the ethyl and the hydrogen, right, to get the hydrogen facing away from us, because that's good. And then here, switch any other group. I just decided to not switch the big bulky T-butyl group because I was feeling lazy, didn't want to draw the extra line. So that got us to here. Now let's assign priority. T-butyl comes in first, isopropyl second, the ethyl group third. We look like we are turning right, and good golly gosh, the hydrogen's facing away from us, so we are in fact R. I hope if you were coming here looking for answers and explanations, you got them. If you're watching this video, gang, that means you've thrown some money and you've supported jOeCHEM, and I so appreciate that. I say that at the end of every video, but I mean it at the end of every video. Thank you for using jOeCHEM as your outlet to conquering carbon. Thanks for having me along for the ride. I hope I'm there until the very end. But if anything, I hope to see you all in the next video.